Hello dear students, this is Vishal sir from Ikra High School. Today I present you chapter 8 motion from class 9 NCERT syllabus. Let's begin the reading from the textbook. In everyday life we see some object at rest and some others in motion. Birds fly, fish swim, blood flows through veins and arteries and cars move. Atoms, molecules, planets, stars and galaxies are all in motion. So dear students, you must have seen objects in motion just like cheetah running, the car driving, birds flying and many other examples that we have seen in our textbook. We often perceive an object to be in motion when its position changes with time. So here, whenever you see any object in motion, that means it has changed its position with reference to time. On some time, it may be at some point. After some time passed, it had changed its position. Only then you can say the object has done some motion. However, there are situations where the motion is inferred through indirect evidences. For example, we infer the motion of air by observing the movement of dust and the movement of leaves and branches of the trees. We never see air in motion because it's transparent object, but we can feel that it is doing motion by looking the other objects which it moves. What causes the phenomenon of sunrise and sunset and changing of season? It is due to the motion of the earth. If it is true, why don't we directly perceive the motion of the earth? The sun rises in the east and sets in the west. The season changes during certain period of time, but we never say that change in season and the changes of the position of the sun is due to the motion of the earth. We directly say sun has risen or sun is at the head during the noon, sun is in the west during the evening. An object may appear to be moving for one person and stationary for some other. Let's see an example. Here you can see passengers sitting in a train where the train is moving and the passengers sitting in are also moving with respect to train. The other objects on the either side of the train seems to be moving while the photo taken from in the train seems that everything is stationary. So the person sitting in the train feels that the outside part is moving, while one standing outside sees that the train is moving or the person inside the train is moving. So the position changes with respect to a reference point. Most motions are complex. Some objects may move in straight line, others move in a circular path. Describing motion. We describe the location of an object by specifying a reference point. Let us understand this by an example. You can see any object in motion with some reference point. You have to first decide a reference point. Here a cartoon is given a position in the initial point, that is the reference point. After that, after some time, it has moved to some other place. So this shows that it has done motion. Any physical movement or change in position or place relative to a reference point is called motion. When you want to describe motion, you have to first fix a reference point, and that reference point is called the origin of that object. Now let's see motion along a straight line. The simplest type of motion is the motion along a straight line. So here O is the reference point. Let A, B and C represent the position of the object at different instants. At first the object moves through C and B. So it doesn't stop at C and B, but it moves from C and B to A. Then it moves back along the same path and reaches C through B. The total path length covered by the object is OA plus AC, that is 60 plus 35, that is 95 km. What is the path that has been covered by the object? It has gone from O till A, that is 60. And from A till the final position C, that is 35. So it had covered near about 95 kilometers. From traveling A to C is 95 kilometers. This is the distance covered by the object. To describe distance, we need to specify only the numerical value. So here we have just mentioned the numerical value, not the direction. The numerical value of the physical quantity is its magnitude. And the shortest distance measured from the initial to the final position of object is called displacement. Thus, the magnitude of the displacement is equal to 35 kilometer is not equal to the path length of 85 kilometer. So displacement is not the total path length covered. Displacement is the shortest distance and distance is the total pathway covered. Sometimes if an object moves from O, reaches C and again moves at O, the final position is at O. So displacement would be 0. If we consider the object to travel back to O, the final position coincides with the initial position and therefore the displacement is 0. However, the distance covered in this journey is O to A and A to O. So here if you look at this position, from you started O to A 60 kilometer and you again return back to O, that is another 60 kilometer. So distance would be 120 kilometer, correct? But displacement would be 0. Your final position is at the same position, that means it is 0. The two physical quantities, the distance and the displacement, are used to describe the overall motion of the object to locate its final position with reference to its initial position at a given time. Now let's see two different types of motion, uniform motion and non-uniform motion. Let's take the example of this diagram. You can see a car traveled from O to A. In 2 seconds it reached to 4 meter. After 2 seconds it reached to 8 meter. After 2 seconds it reached to 12 meter. So you can see the time taken to reach the same distance of time. 0 to 4 is 4 meter, 4 to 8 is also 4 meter, 8 to 12 is also 4 meter, and to reach at the same distance after same time, it shows uniform motion. You can see the difference between uniform and non-uniform motion. An object travels equal distance in equal interval of time when the object is said to perform uniform motion, while in non-uniform motion, it travels unequal distance in unequal interval of time and the object is said to be non-uniform. Here the bike covers 10 meter in 1 second, another 10 meter in second and 10 meter and continues to travel 10 meter per second, then the bike is said to travel by uniform speed, while a car moving in a crowded street. So now let's take a term which measures the rate of motion. How can you measure the rate of motion? Different objects may take different amount of time to cover given distance. Some of them move fast and some move slowly. The rate at which object move can be different. Also, different object can move at the same rate. One of the ways of measuring the rate of motion of an object is to find out the distance traveled by the object in unit time. This quantity is referred to as speed. The SI unit of speed is meter per second. This is represented by symbol meter per second or meter per second. The other unit of speed includes centimeter per second and kilometer per hour. So what is speed? Speed is a measure of how fast a moving object is traveling. Speed is the rate at which distance is covered. It is measured in SI unit of meter per second like this. For cars you will find it is measured in kilometer per hour. Speed is a scalar quantity because it has only size, that is magnitude, and no direction. See, this is how you find the average speed of the car. The car travels 32 kilometers. Total distance traveled is 32 during the first 2 hours. Then it travels 13 kilometers in the next hour. What is the average speed of the car? So average speed is total distance upon total time. So in the first 2 hours it had traveled 32 kilometers. Total distance should be 32 plus 13. This 2 kilometers. And how many hours did it take? 2 hours and 1 hour. That is 3 hours. So 45 kilometer per 3 hour, you can find it like this, or you can divide it 45 by 3 and that will give you 15 kilometer per hour. That means the car has traveled averagely at 15 kilometer per hour. Speed with direction. The rate of motion of object can be more comprehensive if we specify its direction of motion along with its speed. So if you specify its direction with the speed, it becomes more comprehensive, means more understandable. The quantity that specify both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. In the case of velocity of object is changing at a uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity. So average velocity is the initial velocity plus the final velocity divided by 2. That is the average of both the velocities. This is speed, that is distance upon time. This is average speed, total distance covered upon total time taken. Symbolically you have to write it like this. This is the difference between speed and velocity. In speed, the rate of change of distance, and velocity, rate of change of displacement. It is a scalar quantity, this one is a vector quantity. Average speed is equal to total distance traveled, that is S, upon total time t. Where average velocity is total displacement S upon total time. SI unit remains same for both of them. Now let's take another topic, rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any time interval is 0. So when a body is performing uniform motion, and that also a straight line, the velocity remains constant with time. So it does not change, the velocity is same with time. In this case, the change in velocity of object for any time interval is 0. So when the uniform motion is being performed by the object, there is no change in the velocity, and when there is no change in the velocity, it is considered as 0, and that is uniform motion. But in non-uniform motion, velocity varies with time. It has different value at different instance and at different point of path. Thus, the change in the velocity of the object during any time interval is not 0. So what is acceleration? It is a measure of the change in velocity in unit time. That means acceleration is equal to change in velocity upon time taken. If the velocity of an object changes from an initial value u to the final value v, so initial value u to the final value v in time t, acceleration a is equal to, the mathematical expression would be like this. Acceleration would be v minus u, that is final velocity minus initial velocity upon t. This kind of motion is known as accelerated motion. So what is acceleration? Acceleration is the rate of change of velocity, that is speed with direction. It may be positive, negative. If it is positive, it accelerates in the direction is moving up. So if the velocity is here in right hand side, acceleration is also right hand side, that is the car is speeding up. When you speed up the car, when you accelerate the car, it is called positive acceleration. But while you brake down the car, that means you apply brakes to the car, moving car, it is said negative acceleration. Negative accelerates in the opposite direction to its movement. Your car was in the velocity in right hand side, while the acceleration has been applied in the opposite direction. That means it slows down the car, it slows down the moving car.